very good. So one book. Other one, Fluid Mechanics book by Robert Fox. That one also a good book. Then we have some Indian book, R.S. Khurmi, and you will get a lot of books written by Khurmi. Those books are easier to study, but I don't like that much. But they have a lot of problem solutions that help a lot. Okay, you can buy this one too. Then you have Fluid Mechanics and Fluid Power Engineering by D.S. Kumar. And also we have one book that written by one of my two teachers, Kamul Islam, Amulesh Chandra Mondol, of the Buet. Those book is very good book, but I will request you that at least you buy two books. If you're not able to buy two books alone, then share with your friend. Okay, but as a mechanical engineer, you should buy book. Say you are a mechanical engineer and one of your friend visiting your house or your room, but he don't see any engineering book in your reading room. So what will be his or her impression about you? So always better to buy book. Other thing is that after you graduated, say you are going for a job interview, or you join in a company. For example, you are joining in a gas field or fertilizer company or Eastern refinery, and you need to have a real work related to fluid mechanics, but you don't have any book with you. But if you have a book, you can immediately open it. Okay. For example, you working in a CAPCO, a fertilizer company. Say they developed a big tower, and you need to deliver some chemical top of the tower, and they're telling you buy a pump. Now, what will be horsepower of your pump? You need to buy a specific capacity of the pump. So you need the book. So I always suggest buy the book, and also try to save all the class notes. Okay. I am now reverse. Just hold on. Let me change my mouse. Okay. At the you need to buy. Okay. But if you follow the class note and you solve all the problem of the class note, it will be enough for the class. But I always recommend and suggest you to buy book. Okay. Sometimes I might give you a problem from other book. Okay. Now, what is the fluid mechanics, and also why we are studying? That we need to know. I think in 2.2 you have class 1 engineering mechanics, right? Statics and dynamics.
Yes,
so
sir.
Why you study? Anyone? As an engineer, why you need the statics dynamics?
Studying the forces acting on a body. Studying all the forces acting on a body to determine the velocity or acceleration.
Okay. that's good, but why you need to determine the velocity and all the force? One thing that you need to make sure that the body is stable and it is able to carry all the load on the body, load or force. That means, for example, you travel in Coxbazar or Sylhet with 10 of your friends, and you getting top of the hill and sitting on a stone all together, but the stone is not rolling down, is even stable. So what happening over here? How many force is working? Weight of the stone, this one force, then weight all of your friends. They are working at the same time, but the stone is not rolling, is not going down, because all the force working and also the reaction force is working upward at the bottom of the stone. So why is not moving that stone, or why is not rolling down? Because summation of all force and reaction is equal to 0. Similarly, summation of all moment and reaction is 0. You sitting on a chair right now. Why chair is not moving or is not rolling? Because your weight working downward and all the reaction of your weight working upward through the leg of the chair. And the summation, your weight working downward, reaction working upward. Summation is 0. So statics is allow you to figure out whether a body is stable and is not rolling down, or is not rotating, and is able to carry all the force. And dynamics, it determines the stability of a body which is moving. For example, you like to launch a missile from New York to Shanghai. You need to make sure that your missile should not fall down over the Saudi Arabia. It should fly all the way to the Shanghai, right? And during the flying, it should not make change in direction, and it should not break down. So all those things is determined by dynamics. Like you design a motorbike is traveling 90 miles per hour. You making it left turn or right turn. You need to make sure that the bike will be stable condition with the ground. It will have enough friction. It should not skid in the road. Okay. So why I'm saying your experience about course about the engineering mechanics, that while you study, you might don't realize what is the application, but here is the application. We will apply your knowledge of engineering mechanics in the fluid. And also fluid, you will see two types in terms of motion. Static fluid is not moving, other one fluid is moving. For example, you are getting water from your ground floor to the roof tank, right, of your house or building. So in that case, fluid dynamics is working. Then you make a dam over the river, then you put a turbine, water falling down and hitting the turbine blade and giving you energy, mechanical energy. So that work of the fluid dynamics. You working is in a chemical industry, they make liquid nitrogen. You need to deliver liquid nitrogen in a tank or in a truck. Sometimes you see a lot of truck carrying the petroleum, meal, other gas like oxygen in a round-shaped tank over a truck, right? So in those cases, you have to make sure that the structure, that means cylindrical shape object, able to carry your liquid without damaging the structure and also without leaking. So how will figure out? Because you are driving a truck with, say, milk in a cylindrical tank, 60 miles per hour. You make certain brake. What will happen? All the fluid will hit in the front portion. So you need to make sure that the truck or tank is strong enough to carry the load. And how will figure out that amount of force or load? From the principle of fluid mechanics. So what is the fluid mechanics? If we apply the knowledge of general mechanics in fluid mechanics, then it is called fluid mechanics. If we apply that knowledge in a static body, then it is called fluid statics, and other one is called fluid dynamics. Fluid dynamics, normally we teach you in the graduate level. If you do masters, they will study you fluid mechanics. So it is saying mechanics of fluid is the field of study in which the fundamental principle of general mechanics are applied to the fluid. And normally fluid is might be liquid or might be gaseous. So you see, you will apply the knowledge of general mechanics to the fluid. Then it's come fluid mechanics. So what type of knowledge you will apply? Number one thing, you will apply law of equilibrium of static body. Law of equilibrium means in mechanics you study summation of fx equal to 0, fy, fz equal to 0. Then you will apply summation of moment equal to 0. Same law will apply. We will see, we will derive some equation, we will apply that principle. Other thing, you will apply conservation of matter and energy. That energy cannot be destroyed, cannot be created, but you can convert it from one form to other form. So other thing we need to study, compressibility of the fluid. So what is the fluid mechanics? It is a branch of mechanics where law of general mechanics is applied to the fluid. That is called fluid mechanics. So right here I would say fluid mechanics have divided into two parts. One is fluid statics, other one is fluid dynamics. So fluid dynamics deal with the fluid which is moving, and statics, fluid in rest. Okay. Right over here, just showing you the some branches of mechanics. Right, sometimes people say continuous, other word they use continuum mechanics. Continuum mechanics means a mechanics, same mechanics that you apply, you use in the tutu. If a mechanics deal with the solid of mechanics and the fluid mechanics both together, then it is called continuum or continuous mechanics. Then fluid mechanics two types, fluid dynamics, fluid in statics. Then it's showing the fluid dynamics is the stability problem. Then you have turbulent, and fluid statics, you might have multi-phase flow. Multi-phase flow means, say you are boiling water in a pot. There will be two types of flow. You will see after you turn on your stove, you see at first liquid is moving in the pot. Then is generating steam. Then steam also flowing from the top surface of the water, right? That means right over here, two types of flow. That is called multi-flow phase. Okay. Just give you an idea that if we will study only this one, right? But still see there is a huge branch of fluid mechanics, fluid dynamics, multi-phase flow that you can study when you like to do PhD or masters. Okay. Now, how fluid mechanics developed, but is this come automatically in our hand? No, right? So from the ancient period, people living in the cave, right? But for survive, they need water, right? And to get the food, they need to hunt the animal, either by arrow. And to move from one place to another place or to cross the river, they need something. So what they developed? They developed a draft, then they developed a boat. And gradually over the time, they gained some knowledge that they found some trees or plant around their home and they get some fruit. Then they think about the, farming and irrigation. And from that point, concept of fluid mechanics gradually developed. So they have a farming land, they farm the crops, but they need water. And water is 30 feet away from the land. How they can bring it? They have a arrow to hunt the animal, but it doesn't go that much far. So what need to do? They need to sharpen the arrow to make sure that arrows travel faster with higher speed. So from all these concepts, fluid mechanics gradually developed. First, Archimedes, he gives some law of buoyancy force. I think you study in the school too, college, about 250 BC, almost 1,000 years ago, in the fluid mechanics. Then Leonardo da Vinci, at first he designed a canal law, that you have a canal, how we can stop the flow in the canal. You need to make sure that if you put a barrier or a lock, means they put a plate, right? It has enough thickness or strong enough that it should not break down due to the pressure of the water. So you see that a long time ago, about more than 800 years ago. So what I like to say, that from the beginning, gradually fluid mechanics developed. Then there is some other scientists like Euler. Then we have Newton, Isaac Newton. Then Bernoulli, we have Bernoulli's equation you will study. Then you know the name of the Mach, Ernest Mach, or Mach number we study is coming from here. Then Navier-Stokes. These two scientists, Navier and Stokes, both together developed the equation. It's called Navier-Stokes equation. And they're widely used, that equation. And with that equation, you can solve any problem in the fluid mechanics. And a lot of software like ANSYS, other, there is some software you can solve the fluid mechanics problem that comes from the Navier-Stokes equation. Okay. Then in the Venturi, then Boycelis, Weisbach, Darcy, then Francis, and we have a turbine with his name. It's called Francis turbine. Darcy, Weisbach, Darcy, both together derive equations that still we are using. Okay, and the Prandtl scientist from Germany, and we call him father of fluid mechanics because he gave the modern theory that is called boundary layer theory in the fluid mechanics. Then there is some other people like Blasius, Buckingham, von Karman, Reynolds. You will see in the fluid mechanics we study Reynolds number. So they have significant contribution in the fluid mechanics. And here is some picture right over here. It's better to know that how they look like, and from the figure you'll realize about their background. The one coming from the Western countries, from different ethnic groups. Okay. Now, what will be use of the fluid mechanics? That is called scope of fluid mechanics. You see, it is the study of fluid in rest or in motion. That means static fluid or dynamic fluid. Then, if you have knowledge in fluid mechanics, you can apply that knowledge in design of canal, levee, and dam. Right. Another thing, even we are sitting down on the chair, but we are surrounded by fluid. You like to design a efficient ceiling fan. You need the knowledge of fluid mechanics. You design an airplane. You design a ship. You design a pump, compressor. Even you like to design a boiler. You like to design a pipeline. So you are working in a oil company. They like to deliver the crude oil from Chittagong port to Kumilla, and you need to design the pipeline. So you need to have the knowledge of fluid mechanics. Then air conditioning system, there is fluid we use in the air conditioning system. So we need to know that what type of fluid there, when this fluid will boil or become vapor, when they become liquid, how much heat will be transferred from the particular fluid. So in the air conditioning system, you need to know the mechanics of fluid. Then aerodynamics, like you like to design a airplane or fighter plane that fly 5 times higher than the speed of sound. So you need to design. During design, you need to apply the knowledge of fluid mechanics. Same thing in helicopter design. Even if you like to design a drone, you need to have knowledge of fluid mechanics. Other things, a lot of measuring equipment. Say you are filling your gas in the gas station, or you are taking a diesel or octane, how much you are taking. So obviously you need a measuring device, and you need to have knowledge of fluid mechanics. Then other thing, you like to design a wind turbine. You like to get energy from wave. From the wave, also there is a power plant in France. They generate the electricity from the using energy of the wave. Then a large building, you like to build a building, say 200-story height. Then how you design? You need to make sure that building, say storm coming, is 100 miles per hour or 150 miles per hour. So all the building this phase will experience the force from the air or from the storm. So you need to make sure the building will not fall down, right? So if you don't have knowledge of fluid mechanics, you cannot figure out that force. Based on this force, you need to design your building, design your foundation. So this is civil engineer. Also, they need to know knowledge of fluid mechanics. Then biomedical engineering is a huge application of fluid mechanics. You like to design artificial heart valve. Then there is some macro fluid mechanism like LCD TV. It's called liquid crystallized display. We use the LCD. There is a special type of fluid they use. And also, it might be already coming in the market. There's some companies, they are trying to design a TV that it can roll down like a paper. So they will use a special liquid. So you see, without fluid mechanics, you cannot think anything. Everywhere you go, you need to, there is some application of fluid mechanics. And this is some picture of where you see in the airplane, And before airplane, you need to do some analysis using by some software that if the airplane is flying along this direction, then all the here will hit here, right? Then how much will be temperature around right over here, around the engine, around the wing, how much will be the air pressure, everything you can figure out from the software. And you see right over here is the wind turbine. The wind this is rotating, and then you've got the mechanical energy. So there is a huge application of fluid mechanics. Other thing in medical science, you need to know the fluid mechanics because our body maximum part 2/3 is fluid, right? So you see, you like to say design or develop a medicine for heart disease. You need to make sure that your fluid or your medicine will not affect on the blood, or you like to figure out that what will be effect of your medicine in the blood flow. So blood itself a fluid, and sometimes you say there are some surgery, right? If you have heart blockage, how they do? They insert something through the blood channel, right? And it went to the heart and they break the blocks. So in that case also, they need to know the knowledge of fluid mechanics, property of the fluid, that is the blood, they need to know. So are you able to follow me? Hello?
Yes, sir.
Okay. And right over here, what you see is some model of the airplane, model of the ship. Over here is the board. So why I am showing this figure? Say you like to design a fighter plane that will travel 8 times faster than sound, Mach number 8. And obviously you need higher power engine in that airplane or fighter plane. How will figure out that what will be the horsepower you needed? How they do? They make a small model of the fighter plane or aircraft or a speedboat. They put in the wind tunnel. If you visit our fluid mechanics lab, and then you will see we have a wind tunnel. In the wind tunnel, you put in this small model of aircraft or fighter plane, then hook up with the something, some sensor, and air is flowing. Say this aircraft right over here is on the some stand. This is not the real aircraft, that's model, and air is flowing from the front section. So then there is a sensor. Sensor will tell you that how much force is working. Say air coming through the wind tunnel at 30 miles per hour. So at 30 miles per hour speed, how much will be force in the airplane? And its size is 100 times or 20 times smaller than the actual plane. So from that data, you will figure out that how much will be the force, how type of power I need if I fly that aircraft 1,000 times bigger with 500 miles per hour speed. You can easily figure out. Same thing. You have a warship, and you need to figure out that I like to have a speed 60 miles per hour in the ocean. So what type of engine I need? What will be the horsepower of the engine? How will you figure out? You will make a small model of the ship, then you test in the wind tunnel. You put in the wind tunnel, then the wind tunnel, you figure out the velocity of the air. That there is some sensor or you have manometer and pitot tube, you can easily figure out. From that data, you will apply in the real ship that how much horsepower you need to drive that boat or ship in the ocean. So this is very that I'm saying that without fluid mechanics you cannot do anything. Similarly, you like to design a building 200-story high, and you need to know that if storm coming 180 miles per hour, then how much force in the building? I will figure out. You cannot put whole building in the wind tunnel, right? Because it's 200-story height. So what will you do? You can make a small, is scale down. Your building is say 200 stories, that means 2000 feet. You make 1 feet model, then put in the wind tunnel. Then you flow the air in the wind tunnel, and from the sensor you have the force. Then you know that at 10 miles per hour, my model is 100 times smaller than the actual one. Then how much will be force in the real building? So from the law of the fluid mechanics, you can easily figure out. Okay. Now you need to know that what is the fluid, because we are talking about the fluid, right? For example, you like to buy a computer, then what did you know?
Sir, sharing may be stopped.
Sharing or recording? No, recording is one, is still one. So if you like to buy a computer, you need to know what is computer. You need to know what is CPU, what is RAM, what is hard drive, what is USB port. If you don't know anything, then you cannot buy the proper computer from the store, right? So to study the fluid mechanics, we need to know what is fluid and what is its property. You need to know some definitions and some terms. Then you need to figure out some other things, some equation or some derivation, and you need to know how you can figure out a problem or you can solve certain problem. For example, you like to design a dam. If you see all the dam or how look like, top is narrow, bottom is wide, but why? It is coming from the law of fluid mechanics, because at the bottom pressure is high, at the top pressure is low. So what I'm saying that to solve particular problem related to the fluid mechanics, you need to know some certain terms. What is the property of the fluid? If you know, and what is the certain law of the fluid? If you don't know, then you cannot do anything. Similarly, if you like to buy a computer, you need to know what is the RAM, how much capacity of the RAM is available, and what is the function of the RAM. If you have all the knowledge, then you can buy a good computer or you can design a good computer. Similarly, if you know all the terms of the fluid mechanics, then you can apply the knowledge of fluid mechanics in the real life. So let's see that what type of things we need to know. Number one thing, we need to know what is the fluid. I think you already know it. So it's saying fluid is a substance, either liquid or gas phase, which is capable of flowing. Fluid always flow from one place to another place, and it has no definite shape conformed to the shape of the containing vessel. Is always take the shape of the containing vessel, and fluid cannot support shear force and deform continuously to minimize applied shear force. So two things we write over here. Number one thing, what is the shear force and what is the deform? Deform means Bangla, Bikriti. You have bucket of water or you have a tank of water in your home, and this level is water, but you put your hand, you're able to move your hand, right? So you will not feel that much resistance. But the same tank, if I fill up the honey and I tell you move your hand inside the honey, you will feel, obviously you will feel more force, right? You have to be more stronger to move your hand. Then if I fill up the same tank with tar, Bangla Alcatra, and I tell you move your hand, you might be able to do it, but your hand will be more messy and you need to have more force to move your hand. So what you see from that example, that the resistance flowing giving you is different in different type of fluid. So that means you like to move your hand, it allows you to move. It don't give that much resistance. But if I fill the same tank with solid object, you cannot move your hand. So that is saying fluid cannot support shear force and it deforms continuously. Whatever you move your hand, it deforms. That means its shape will not remain in a stable condition to minimize the applied shear force. So this is the definition of the fluid. So it have two things. Number is the liquid, other one is the gases. So what is the liquid? A liquid possesses a finite volume, which varies slightly with temperature and pressure. Under ordinary condition, liquid are difficult to compress. It is very hard to compress the liquid. Say you have a cylinder and you put some liquid, water, and you have a piston. And you try to force with the piston downward, you need a higher force to push it. And you can push it just a little bit, not that much. But the same cylinder, if it is filled with nitrogen gas or oxygen gas of air, you are able to squeeze by applying bigger force top of the piston. So that is a liquid is normally incompressible. And gases is a fluid which is compressible and possesses no definite volume, but it always expands until its volume equal to the container. For example, you are sitting in a room right now. Your room is full of air, right? So if I close all the window, all the door, conceal it tightly, then take out all the air. Okay, so there will be no fluid inside the room. Now you put just 1 gram of oxygen or 1 cc of oxygen in that room. What will happen? All the oxygen molecular distance between one molecule to the other molecule will be increased. They will gradually expand and occupy the whole room. Even if you put the 1 pound oxygen in the room, all the oxygen will be expanded and it will fill every space of the room. So that is the one important property of the gases. And inside the fluid, normally you cannot see any vacuum unless you have some bubble. Bubble also filled with air, right? So it says that gas is compressible and it will occupy all the space of the container, and it don't have any finite or fixed shape or volume. Fluid also classified as, other thing is ideal fluid, and other one is called real fluid. We will talk about later on. What is the ideal fluid? That is ideal. That means it follows the law of the fluid, some certain law. But in reality, some fluid does not follow that law. Okay. So we'll talk about later on what is ideal fluid and what is ideal fluid. Any questions so far? Anyone?
Sir, fluid cannot fluid cannot support shear force and deform continuously. So this
Yeah.
point not clear, sir.
Not clear. Okay. Deform continuously. For example, you see in the river. In the river, what happened? Is water is flowing downward, right? And you see, especially if you see the river in the rainy season, you'll see height of the water in the river. In all the places same, is not the same. Height of the wave, all the wave is not the same. Again, you have the bucket of water, you have the fluid water, then put your hand and try to move. What will happen? You put your younger brother or sister, tell him that you move your water inside the hand, move your hand inside the water. He are able to do it, right? But if she put the water hand and do like that, what will happen? Water, you take it out of his hand, water will rotate, right? But if your younger brother or sister put their hand, it will rotate slowly because turmoil or deformation is not that much, since his hand size is smaller than you. But you put your hand and try to rotate, it will allow you to rotate. Then take it out. You will see fluid is moving, rotating with longer time and with higher speed. Why? Because this time you deform more in the fluid. You apply more force to have higher deformation in the fluid. You got it?
Yes, sir.
And we'll study later on more that what is the shear stress of the fluid, what is the deformation of the fluid. So shear stress, other thing, you have a boat. And this boat, especially in the Coxbazar, you see when there is just sitting on the mud. You try to push. Okay, and same boat just sitting on the water. And where you need higher force? Obviously, you move this one, you need higher force because there is no semi-liquid, right? If I say the mud is also liquid, but not the 100% it has property of the liquid. So it will take higher force. Right over here, it will be less force. Okay. And we'll discuss later on. We'll derive a equation that how we can figure out a shear force in the from a liquid. But you need to know what is shear force. Shear force that work parallel to the surface. For example, you put your hand just like that, top of a glass. Right? Say you have a table. Table has a glass on the top. You put your hand on the table, on the glass, and try to move. You can move easily, right? Because in the glass surface is smooth, it don't have that much shear stress. But you take out the glass. Say you have a wooden surface, a little bit rough, try to move your hand. Obviously, you can move it, but you need a little bit higher force. So that is the example of the shear force, but shear force always work parallel to the surface, parallel to a plane. Okay. I am giving lecture in English, so do you feeling any problem to understand? Anyone? It is okay? You can follow?
স্যার আসসালামু আলাইকুম।
Walaikum salam.
স্যার বাংলায় যদি বলেন তাহলে বেশি ইজি হয় বুঝতে, কিন্তু ইংলিশে প্রবলেম হচ্ছে না।
Yeah, you will have some problem in the English, but there is a problem that when we got accreditation from IBE that your certificate. With that certificate, you have good CGPA, you can get admitted, or you have a good GRE score, you can admit it in any university around the world, in Australia, Canada, or US, because they are studying their student, teaching their student, and we are teaching you with the same material. And they like to know that the same language we deliver during in the class. Okay, and what happened? Say you have a very nice university in Singapore, and they like to say, okay, we'll take your student in my university for higher study. So what do we do? They will visit our university. They like to see our syllabus, our course content, how many courses we have. Then they like to see the grade of the student, how we evaluate, and how we deliver the lecture in the class. So there is a problem as per UGC and also the university authority that we should deliver the lecture in English. And other thing, at the beginning it will be a little bit tough for you, but it will be also beneficial when you go for higher study. Even if you go in IUT or BUET, you see a lot of teachers, they're giving lecture in English. But if you have problem to understand, we have several spots in the routine. Or you can call me, you can give me a time, anytime. I can make a separate Zoom session and explain you Bangla as much as possible. Lot of time is difficult to make some Bangla term, but still we can explain you better. Okay. So that makes sense a little bit. Hello.
Yes, sir.
Okay. And I think you already second year, it will be okay to understand after a few class. I think it will be okay. Since even we live long time in other country, but our pronunciation, our accent still is Asian accent. Okay. So it will not be tough to follow, that I believe. Okay. To know the fluid, we need to know some term. Same thing, to like to buy a computer, we need to know some term. What is RAM, what is hard drive. So here is the some term. Number one thing we need to know, what is the density, what is the specific volume, then what is the specific weight, specific gravity, viscosity, then kinematic viscosity, compressibility, surface tension, capillarity, vapor pressure, and fluid pressure. All those things, definition and the term, we need to memorize and need to understand. We'll use some Greek letter to express those properties, like density is called rho, then this is small v, specific volume, gamma, this is mu, this is mu, is called kinematic viscosity. Okay. And then also we'll use beta, compressibility, then we'll use sigma. Okay. So so far, any other questions? Anyone? No? Okay, we'll stop it here today because I have a meeting in the department. Right now, I need to go to the department since it's the first class. We are stopping over here, but still